Okay, you guys, we're going to extend what we talked about yesterday on finding the circumcenter of a triangle. And I've got two different triangles here. And remember, the circumcenter is where the perpendicular bisectors from all three sides of the triangle intersect. That's going to be your circumcenter of the triangle. Now, the one on the left here, triangle ABC, the circumcenter is going to be in the center, but I did the one DEF here to show you that the circumcenter doesn't always have to lie inside the circle. It can lie outside the circle as well, but it's still a circumcenter. So take a moment, pause, grab a compass and a straight edge and draw a couple of triangles like this and get a compass out, and we'll go through the steps on finding the circumcenter. Okay, now that you have your triangles drawn, you're going to take your compass, and I'm going to do line AC, line segment AC first. So I'm going to put my compass point on point C, and I'm going to make sure it's at least more than halfway, excuse me, between A and C. And I'm going to draw some arcs. We'll draw an arc there on the top, and we'll draw an arc here on the bottom. Bring this down so you can see it a little bit better. Okay, and then we're going to flip our compass and not change the compass heading. And I'm going to put my compass on A, my point on A, and draw an arc that crosses there. And I'm going to draw an arc that crosses there. So once I have those arcs, I'm going to go ahead and get my line tool out here, and I'm going to draw a line that cuts through my triangle like that. And it's not going to be perfect digitally because you can see it looks a little off there, but I'm going to go ahead and make that. Let's make that line red so it's a little easier to show up. There. Okay. So we've got that. So this line right here that I've drawn is the perpendicular bisector from A to C, and that's going to make this distance right here and this distance right here equal, right? So this is going to be the same distance as from there to there, okay? And another thing I like to do, and I told you this yesterday, after you've drawn your arcs, or your perpendicular bisector, excuse me, you don't need to, but it's kind of nice to delete your arcs or erase them in your case if you're doing paper pencil. And that way you won't get messed up on what arcs you're trying to do. Okay, so go ahead, pause right now, and do the perpendicular bisectors for BC segment and for AB segment. And then I'm going to go do the same. Go ahead and pause your video. And when we start, I'll show you what mine looks like, and you can compare them. Okay, now that we have our perpendicular bisectors, and we can indicate their perpendicular bisectors by the 90-degree symbol on all three of them, we have this point right here. That is indeed the circumcenter of your triangle. Okay, now there's one thing I need you to note. I'm going to draw a line from C to the circumcenter. Well, let's do it this way. I'll draw a good line for you. I'm going to draw a line. That's not it. I need my line tool. There we go. All right. So we're going to draw a line from C to the circumcenter, right there. Okay. And we're going to draw a line from C to the circumcenter there. And then you've got from B to the circumcenter there. So you can tell if it is truly the circumcenter that those three lines are going to be equal. In other words, from the circumcenter, all of the vertices on the triangle A to the, well, let's call this F. Let's call this point in the middle here, the circumcenter, let's call that F, point F. So the distance from A to F, the distance from B to F, and the distance from C to F is going to be equal, and that's going to be important when you start solving some stuff, distances for triangles, okay? So now, take a moment, draw a scalene triangle like triangle DEF on the right over here, and draw some perpendicular bisectors through that. And this incenter is going to fall outside of the triangle, and I'll show you the difference. Okay, here's what my scalene triangle looks like with perpendicular bisectors. That's a 90, that's a 90, and that's a 90-degree angle. And notice this point is right here, outside of the outside of the triangle. It is also a circumcenter of a triangle. Now, here's what you need to note. The same holds true for this circumcenter as it did before. This distance from here to here, from here to here, and from here to here is equal. So the green dashed line there, these are all equal in length because they are, so from the vertices of the triangle, they're equidistant from the circumcenter of any triangle, whether it's inside the triangle or whether it's outside the triangle. Okay, so when we find the incenter, what we're going to have to do is find an angle bisector. And you're thinking, what? Well, a while back we did angle bisectors. I'm going to show you how to construct an angle bisector. Let's go back to this triangle. If we have triangle A, we'll put B up here and C down here. Okay, it's a nice isosceles triangle. So basically what an angle bisector does, it cuts an angle, splits it in half, essentially. Okay, so in order to do that, I'm going to start by taking and putting my compass point on A. Okay, and then let's flip this. I'm going to put my compass point on A, and I'm going to draw an arc across this whole angle A. Okay, just like that. Then, without changing my compass heading, I'm going to come over here and put it on this point where my arc crosses the line. I'm going to make an arc up here, flip my compass, and I'm going to put my point where it crosses the other arc, and I'm going to make an arc right there. Now, if I take from the vertices through this point where my two arcs are, that's going to create an angle bisector. So let's do that in, I don't know, green, maybe? Let's do it in green. We'll make it dashed. So this, from here through that point, right there is an angle bisector. What that essentially does, let me clean this up a little bit for you. I'm going to move my compass off the way. Let me get rid of these arcs. Okay, maybe. Okay, so that right there made that angle equal to that angle. So both those angles are equal, right? Because I cut them in half. So now you try. Actually, I'll do another one with you. Let's put our compass on point B. Okay. And I have to turn this around, so I'm running out of room. Okay. So now I'm going to do the same thing. I'm going to draw an arc across this whole angle B. Okay. I'm not going to move my compass heading. I'm going to take my compass. I'm going to move my compass heading. I'm going to put it on that point right there. Bring my compass around, and I'm going to put an arc right here. Switch my compass. Put it on the other piece of the arc, and make another arc right there. Okay. And again, it's not going to be perfect because it's digital. And we're going to draw an angle bisector from point B through that point right there. Okay. So that's an angle bisector there. Now it split angle B in half. I'll get rid of some arcs to make it look better. I would suggest you do that too. It's less confusing, so have an eraser handy. So there's the angle bisector for B, okay? And then angle C. Go ahead and pause and see if you can do angle C by yourself and come back and see what it looks like. Okay, once you've found all three angle bisectors, it should look something like this. Now you'll notice the two red marks indicate those two angles are equal. The double blue marks on top indicate that those two angles are equal, and the three green marks on angle C means that splits that in half. Now there's this point right here in the center of this triangle, and that in fact is called the incenter. Right? That's the incenter. Now the thing to notice about the incenter, when you do angle bisectors for all three angles, there's something special about, let's see, we'll make it red. That line, and that line. Now they're not necessarily a 90-degree angle to the sides, but they are the same distance, right? So if it's the incenter angle bisector, the lines are equidistant from the sides, okay? And if it's a circumcenter, from the vertices to the circumcenter are all equal as well, okay? So that red tick mark right there means that those are all equal, those lines, or those segments, I should say, okay? So that's finding the incenter. We didn't go over that yesterday, but incenter is an angle bisector. Circumcenter is a perpendicular bisector to the sides. So I have an example here, okay? Go ahead and pause your video for a moment. Write this down in your Cornell notes, probably on the right side, and then write down K is the incenter of ABC, find KF, which is a line segment, and find the measure of KAC, which is an angle, okay? So look this over, copy it down, and then start the video up, and we'll figure out how to solve this. Okay, now that you have this drawn, let's just take this in two parts because it wants two things. It wants you to find KF, which is a line segment, and the measure of KAC. So first I'm going to find KF, which is this distance right there. That's KF, right? I need to know what that is. Now, you know from the previous example that when in incenter, you know that this line has to equal that line, has to equal that line, because these are angle bisectors, right? They cut angle B, angle C, and angle A in half, basically, with an angle bisector to find the incenter. So those three red tick marks there mean that those lines are going to be equal. So if I can find one of them, I don't need to do the math on the rest of them. They're all going to be the same. So I'm looking at what I know here, and down here on this triangle of DAB, right? They give me a side length right here of 13 and a side length of 12, okay? So I know, and I know you guys know, hopefully, this is a right triangle indicated by that right there. So I can use the Pythagorean theorem to figure out the third leg of this triangle, okay? Let's call this, let's call this side A. We'll call that side B, and that side C. And the Pythagorean theorem says that A squared plus B squared equals C squared. So, given that, I don't know A, but I know B and C. So I'm going to say A squared. I'm going to plug the numbers in. B squared is 12 squared, and C squared is 13 squared. Okay? So, I'm going to do a little bit of math here. A squared plus 12 squared is 144. And 13 squared, I believe it's 169, but I'm going to check myself here on my calculator. Okay, so 13 squared is 169. If I go back here, that's going to be, now we just do some math. We're going to take 144 from each side to get A by itself. I'm going to have 25 equals A squared. Let me rewrite this. A squared is 25. And in order to get rid of this square on A squared, I square root that side, square root that side. So A is going to equal 5. Okay, so I know that leg A is 5. So let's do a little revision here. I know what B and C is. So A is going to be 5. Now, I know if A is 5, KF is also going to be 5, and that answers my question. Find the distance of KF right there. So line segment KF equals 5. Well, and so does EK and DK. All of them equal 5. Now then, let's look at, that's 5, that's 5. I'll just put those back in there, that's 5. Okay, now we're looking at the next part of our question, which is find the measure of KAC. So we've got K in the middle, right? KAC. I need this angle measure right there, okay? I need this angle measure. So what I'm going to do, let's clear my board off here. So KAC is this angle right there. That's what we're looking for. Well, you can look, and you know these are angle bisectors, right? Because it told you that it's the incenter. So I know that this is 28 degrees, and I know that that's 36 degrees. But I don't have either of these. Well, you know that there are 180 degrees in a triangle. So you can go 2 times 28, which is angle B, plus 2 times 36, which is angle, what is that? Angle C. Okay, plus, we don't know. Let's call this angle, let's call angle, the whole angle A, let's call it, I don't know, X, equals 180 degrees, okay? Okay, so if we do the math, we get 56, 28 times 2, plus 2 times 36 is 72, plus some number X equals 180, okay? Add 56 to 72 and subtract it. So if we just do that, 72, that's going to be 8, 12, 128. So on the left side, we're going to have 128 plus X equals 180. If I subtract 128 from 180, it's going to leave me X on this side. And over here, we're going to have 52. So X is 52, but now notice X is the whole angle, right? It's the whole angle. And we're actually not looking for the whole angle. We're looking for half of that angle, because if you look here, this whole angle right here is 52 degrees. So we need to take half that to get each side. So I'm going to divide 52 in half. I'm going to get 26 degrees. So that measure of that angle, this one is going to be 26 degrees, and that one's going to be, not 27, that one's going to be 26 degrees for a total of 52, okay? So you need to know when the incenter that is equal, and you need to know if you're finding a circumcenter, the vertices to the circumcenter are equal. So make sure you have good notes on this, and we will have an assignment when you're done with the notes.